Here we have day 2 of our 21.1 notes. So today we're going to call it 21.1b. 21.1b notes. More on probability distributions. Now yesterday towards the bottom of the notes we found that probability of multiple events happening, there's a formula for it, and the formula is the same as what was written on the bottom of yesterday's notes. It just wrote it again up here so we could see it again. Probability of A happening and then B happening is equal to the probability of A happening times the probability of B happening. So if one coin is tossed, the probability that the coin lands on heads would be 1 out of 2, because there are 2 possible outcomes and only one of them meets that requirement of being heads. Probability of it flipping and being tails would be the same. One of the 2 possibilities is tails. What about if 6 coins are tossed? What's the probability of getting heads, 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 heads? All 6 of them flipping to heads. Well, that's where our A then B, heads, then heads, then heads, then heads, then heads, then heads. We would do the probability of heads times the probability of heads on the second roll, or toss, times the probability of heads on the third toss, times the probability of heads on the fourth toss, fifth toss, sixth toss. That gives us a grand total of 1 out of 64. Okay? If 6 coins are tossed, what happens, or what's the probability if you have the first 5 coin tosses giving you the result of heads, and then the 6th one, the last toss, you get a tails? Well, that's actually the same. Because the probability for heads and the probability for tails is the same, here's your first flip, second flip, third flip, fourth flip, fifth flip. Your 6th flip, even though it's the other side, is still 1/2. So that still gives you 1 over 64. So there's our probability right there. Now let's move on to a histogram. Let's see. Actually, before I go on to the histogram, let's read through this. The probability of getting 5 heads and 1 tail in any order is more complex, because you have to consider that you could have heads, 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 tails, heads, 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 tails, heads, 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 tails, heads, heads, and so on. So the tails could be flipped anywhere within those 6. So we get a probability of 6 out of 64, not just 1 out of 64. The reason is because the probability of this is 1/64th. The probability of this is 1/64th. This is 1/64th. This is 1/64th. This is 1/64th, and this is 1/64th. But it's not this, then this. It's this option or this option. Now the word or is kind of important there. If it is this circumstance or this circumstance or this circumstance or, you actually add the probabilities. So you would have your 1/64th that you calculated up here, plus 1/64th, plus 1/64th, plus 1/64th, plus 1/64th, plus 1/64th, and that gives us our total of 6/64ths. So we get a probability of 6/64ths, not just 1/64ths. There's an easier way to find this, but only the honors classes need to cover it, so we're not going to go there. So the following histogram shows the probability distribution. So the probability distribution has already been done for you. So what this probability distribution shows me, this is all theoretical probability, this is not an actual experiment, is that if you were to flip a coin 6 times, or flip 6 coins, for example, the probability that only one of those 6 coins, the probability that 0 of them are heads, meaning that they're all tails, is 1 out of 64. The probability that of the 6 coins you flipped, that one of them is a head and the 5 others are tails, is 6 out of 64. The probability that 2 of the coins land heads up and the 4 remaining ones are tails is 15 over 64. The probability that you have half heads and half tails is 20 over 64. The probability that 4 of them are heads and 2 of them are tails is 15 over 64. The probability that 5 of them are heads and 1 of them are tails is 6 out of 64. And the probability that all 6 coins end up being heads up would be 1 out of 64. So How can you tell that the coins tossed are fair coins? Well, here's how I can tell. The histogram is symmetrical. Or symmetric. Since it follows a very symmetric pattern, you have a larger value in the middle, and then you have matching values, matching values, matching values. It is perfectly symmetrical, and that tells me that the coins are fair coins. There's no funny business going on here. If you and your friends each took a turn and tossed Chris's 6 coins, apparently this guy's name is Chris, and all of you got nothing but tails, what would that imply? Well, to me that would imply the coins are unfair in some way. Because that's most likely not going to happen. If you flip 6 coins and you are constantly rolling or constantly flipping all tails, there's something going on with the coins. They're either weighted some way, or maybe they have tails on both sides. I would say that they are not fair coins. So it could happen, but it's highly unlikely because of how low the probability is there. Okay, so let's complete this table based on the histogram. The number of heads tossed when you have 6 coins. Well, you could toss 0 heads. You could toss 1, 2, 3, 4, 5, or all 6 of them could be heads. The probability of 0 is 1/64th, of 1 is 6/64ths, which actually reduces to 3/32. The 2 heads would be 15/64ths. 3 heads would be 20/64ths. 4 heads is 15/64ths again. 20/64ths, I forgot, that actually reduces to 10/32. 5 heads would be 6/64ths, and 6 heads would be 1/64th again. And again, 6/64ths reduces to 3/32. I think those are the only ones that'll reduce. So, use the table and or the histogram to find each probability from 6 tossed coins. The probability that you flip at least 2 heads, remember at least 2 heads means 2 heads or more. So that would be the probability of flipping 2 heads, or, and or means we add, the probability of flipping 3 heads, or probability of flipping 4 heads, probability of flipping 5 heads, and the probability of flipping 6 heads. Well, the probability of flipping 2 is 15/64. Probability of flipping 3 is 20/64. Why am I using the not reduced form? Because they all have the same denominator. Probability of flipping 4, 15/64. 5 would be 6/64, and 6 would be 1/64. And if I add all those together, get 64 as the denominator. 15 plus 20 plus 15 is 57/64. Oops, sorry, 57, not 56. And that doesn't reduce, so that's my probability right there. 57/64, that's a 7. Okay. The probability of flipping less than 2 heads. Less than 2. That means the probability of flipping 0 or the probability of flipping 1. Not the probability of flipping 2, because this says less than 2. It does not say less than or equal to 2. So the probability of flipping 0 from up here is 1/64. The probability of flipping 1 is 6/64. Adding those together, I get 7/64. Okay. What about the probability of flipping an odd number of tails? Let's think about this for a minute. If I flip 0 heads, that means I have 6 tails. That does not fit there. So what about 1 heads? That means 5 tails. So that would be my probability of 1 right there. That's an odd number of tails. 2 heads would be 4 tails. That's not odd. 3 heads would be 3 tails. That is odd. 4 heads would be 2 tails. That's not odd. 5 heads would be 1 tail. And that is odd. I'm running out of room there. And thankfully 6 heads would be no tails, and that does not fit there. So that would be the probability of 1 plus the probability of 3 plus the probability of 5. So that means 6 over 64 plus 20 over 64 plus 6 over 64. And that gives me 32 over 64, which reduces to 1/2. And finally, the probability of flipping 8 heads is 0. Why? Because you only have 6 coins. There's absolutely no way you can flip 8 heads if you only have 6 coins. Just saying. All right. Let's see. Your homework tonight is worksheet. Let me check what it is. It is worksheet 21.1b. What it is it's problems number, it says 5 through 8, but it's actually 5 through 7 in your textbook. Same page as last night, but I went ahead and printed it out on paper for you so that way you can do it. So you can either do it out of the textbook if you lost your paper, or you can just do it on the worksheet that you hand out in class. All right, happy studying.